Hello, and welcome to our virtual Lunch and Learn. Today we're talking about configuring Rockwell Automation's CR30. My name is Leanne Ireland, and I'm the Marketing Project Manager here at McNaughton-McKay Electric Company. Presenting for us today is Kevin McDonald, Industrial Control Project Manager out of our Greenville, South Carolina branch. We will also have a Q&A portion at the end for Kevin to answer your questions. Please put them in the comment section. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comments. Hi, Carol. Thanks for joining us today. You can view recordings of our previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. And we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. For everyone just joining us, welcome to our virtual Lunch and Learn, Configuring Rockwell Automation's CR30. Let us know where you're joining from in the comments. We'll be looking for questions as you have them in the comments while our presenter, Kevin McDonald, shows us how the CR30 acts as a tool to create a flexible and dependable safety system. Kevin will respond to your questions in the comments at the end of his presentation. If you'd like to reach out afterwards, or if you have further questions for Kevin, you can send us an email at macamaclive@mc-mc.com. Be sure to let us know which session you attended, and we'll direct your questions to Kevin. We'll have the email address on the screen for you at the end as well. It looks like we have quite a few attendees now, so let's get started. Kevin, I'll pass it over to you.
Thank you, Leanne. Hello, everyone. Welcome, and thank you for attending MacAMac's Virtual Lunch and Learn. Today, we're going to talk about configuring the CR30 configurable safety relay. And the first question I'm going to start off with is, why do we call this a configurable safety relay and not a programmable safety relay? And the answer is pretty simple. If we call it a programmable safety relay, we'd have to charge you a bunch of money for the software. If we call it configurable, our software is free. So the CR30 is configured through Connected Component Workbench, same software we use to configure our drives and our Micro 800. So with that, what is the CR30? So the CR30 configurable relay consists of 10, the first 10 on the top terminals, 0 through 9, those are dedicated input terminals. And they're all safety rated. This can do 5 redundant devices. So the next two, 10 and 11, they can be a dedicated safety input, or they can be both configured for single wire safety. Down here at 18 and 19, those are dedicated safety outputs. 20 and 21, those could be dedicated safety outputs, or they can be configured for single wire safety outputs. And we'll be discussing more about single wire safety in a bit. So the trick and the key to all of this is these 6 terminals here, 12 through 17. These are our multifunction terminals, and they can be configured as a safety input, can be configured as a safety output, or they can be configured to be the output of a pulse train through our e-stop circuit to allow us to get to category 4 safety. We also have 2 expansion relays, or expansion slots. Our programming port, this is just your standard USB printer cable. We don't even sell a configuration cable. Go to your ID department, they got everything on Ethernet. I'm sure they have a bunch of these cables laying around. The other thing is we have diagnostic LEDs as well as configurable LEDs, 9 for your inputs and 9 for outputs. So this will be a short PowerPoint presentation that I'll give. Yay. And then we're actually going to do a live demo. I'm going to attempt to configure the CR30 in an attempt to show you how easy it is to use. We will also go in further detail on the single wire safety. We'll also talk about the plug-in expansion slots. And then I'm not going to talk about the serial port. It's available there to be connected to other devices, but in the end, I'm going to show you why I believe this serial port's mostly obsolete nowadays. All right, so the CR30 is very easy to configure. In Connected Component Workbench, you're going to see this live. Basically, you start out by configuring the CR30's hardware. Then we're going to go in and we're going to configure the logic. And then we're going to test and validate, and then do a verification side. Everything in this is drop and drag. Simply go to the menu, drop it in there. Very simple to use. One of the things that this features in free software is the ability to go online and monitor live what's going on. And it's a very useful tool. Here it shows that we have a gate switch that's tripped out and it's in red. And it actually tells us we have one of the inputs and not the other. It also pops up with a description of the actual fault, telling you exactly what is wrong with this fault. Single wire safety, if you don't know, is the ability to transfer the status of one relay to another. And where we see it used most in the CR30 is on our expansion modules. And the CR30's outputs are solid state, so you can direct 24 volts. Well, sometimes, especially in like robotic cells, you need dry contacts to give feedback back to the robot. So they're going to send out a safety signal. We close contacts, and they see that it's arrived and that everything's safe. In here, our expansion modules, they come with 4 additional dry contact outputs. And so through a single wire, when this is safe, these contacts close. When it's not safe, these contacts close. One of the biggest things we use the input for, we had a large OEM customer who had 25 input devices and only 2 output devices. And they refused to put the safety in a Guard Logic Safety PLC. And they needed category 4, so every device had to land on terminals. So what we did is we took one CR30 and put 9 inputs on it, and we single wired the safety out of it into the input of a 3rd relay. We did this exact same thing on a 2nd one and brought it into the 3rd relay. The 3rd relay had several other inputs, and these 2 sums of the 18 inputs off the 2 CR30s, thus able to AND all together. And when all 25 devices were safe, we had the dedicated outputs going to 2 contactors, but we also used these other 2 to go to the safe torque off in the drive. Very successful project, and they've duplicated it probably around a dozen times now. So our expansion modules. Now, our expansion modules are not safety rated inputs. And it's key to understand this is the new trend for all of Rockwell safety devices. If it's actually safety rated, it'll be red, but the non-safety rated will be gray. So why do we have non-safety rated inputs and outputs? Well, it's simple. Is the reset button an actual safety rated device? No. Think of it this way. If we lost the reset function, do we lose the safety function? No, we do not. We just use the ability or lose the ability to reset the safety function. This also goes for our feedback monitoring. Our feedback monitoring is the normally closed auxiliary contacts on our safety rated contactors. Now, our safety rated contactors are mechanically linked. So if one of the contacts arcs and welds shut, all the other two are going to hold closed. This keeps the auxiliary open. And when we feed this back to our reset circuit, you lost the ability to reset. Thus, you have to troubleshoot, and you have diagnostic coverage that one of your safety rated contactors are bad. This also goes for the muting sensors on muting light curtains. If they go, you lose the ability to mute light curtains, not the safety function themselves. One of the most important ones we're going to talk about, and the reason that I say the serial port is obsolete, is we have an Ethernet IP communication module, and this thing becomes very valuable. This allows us to monitor every terminal on CR30, all the safety functions, the output functions. It even allows us to monitor the logic. It tells us what our faults are. Not only that, but through the add-on profile in Studio 5000, now we have the ability to communicate or to configure the CR30 through Studio 5000. And we never have to leave the Studio 5000 environment. Here's an example of the architecture and the way it would be used with our software connected to a controller and connected to the HMI. Through this diagnostics, now the HMI can actually tell us door number 2 is open is our fault, giving us a lot of power in the CR30. The add-on profile has a configuration tab located here, and with it, it looks almost identical to connected component workbench, allowing you to configure the CR30. The big thing that it also does is that add-on profile automatically creates a lot of control tags located in the control tag database. And these control tags, again, have tags for every terminal, every safety input device, output, and etc. So it allows you to monitor the CR30 completely. It also gives you the ability to communicate, and we'll see that in the demo, communicate non-safety to our CR30. So it's very simple to use. You just simply download the project, open the add-on profile, go to the configure tab, configure it, and then download it to your CR30. And then you're able to also have a live view of the CR30 as it's playing. All right. This right here is just to show you, we have a lot of documentation on the CR30. CR30 is very easy to use, and there's a lot of resources. This is just an eye chart showing you how much information is available. Now with that, that'll end our presentation, yay, and we'll go into an actual live demo. So we open up Connected Component Workbench. And what we're going to do to create a new project is we just start with new. Give the project a name. Hit create. We go to devices, and under safety relays is our CR30. Click on it, and then you can see that we have multiple versions. You can actually open this in an older version if you've got an old relay out there with not updated firmware. Currently, we're on firmware version 10. Hit add to project, hit select, then add it to the project. Here, if you right click on it, we can go ahead and this will automatically upgrade the firmware to your device. Whoops, I don't want to delete it. We're going to rename it, and we'll just call this. And we've named our CR30. One thing I will tell you, you can have multiple CR30s in a project, but you can only have one CR30 in a CCW project. All right, so this will bring us, when we click on that, this will bring us to our hardware configuration page. if you right click on the expansion slots, under the left slot is the only place you can put the Ethernet module. And we'll go ahead and click that. Tells us our serial port's obsolete. What I'm about to do right now, I should have said this beforehand, is I'm going to recreate the actual program on the demo board behind me. All right, and it has an Ethernet module. You can use DHCP to address this, or you can go ahead and manually configure an IP address. So I'm putting in my address that I'm currently using, and we've now put in the address. I also have a digital 4-in 4-output module on this device. And we've created the hardware. We can also go in here, and this allows us, we showed you that we have the LEDs to use for diagnostics. You can click on the LED, give it a terminal status or a function, and this will actually be our first device that we have in our configuration. And we can do this through all the LEDs that we're using. Down here, we can use this as an output function and thus configure our LEDs. One thing I do want to point out is we do have a fault log. And the way the fault log works is the last fault will be the top of the fault log. And then as new faults come in, they stack on top and resend the older down to the bottom. All right, so we have now configured the hardware portion of our CR30. Now we're going to go up here to the logic editor, and we're going to start creating the logic. I'm going to go ahead and close this project organizer out. This will give us more space to allow us to see all the 4 rungs. And the first rung going vertically here, this will be all our input functions. And we got 2 levels to put our logic. And then on this 4th column, this will be our output function. And here is our toolbar. And our toolbar consists of all our input devices. And notice some of the input devices we have: muting, safety mats, 2-hand control. This becomes a very versatile tool to allow us to use a lot of input devices. Here's our logic. And then down here, this portion is our output functions. So with that, we're going to get started. And I'll just drag over an e-stop and put it as the first device. Now it automatically gave us these addresses, but we do have the ability to change these addresses. We can use any of the 12 input terminals or any of our 6 multi-function terminals. We'll just leave it as it is. And notice that they did put terminal 12 and 13 as our pulse width for our e-stop circuit. So essentially what we're going to be doing here is we're going to go out 12 through the e-stop and into 0, and out 13 e-stop into 1, creating our e-stop circuit. Next, we'll add the light curtains. Now light curtains are solid state devices, so they're not giving us those sources. Now one thing I want to point out, if the box that you intend to populate it is highlighted green, you can go over to the toolbox and just double click the device and it'll show up there. And we actually have 3 gate switches. So we'll go ahead and put them here. And I'm going to rename this. If I right click on this and hit rename, and I can call this our MZ guard locking switch, hit enter. Can also just double click it. It's not working. And we'll call this the GD2, enter. And I'll call this the EZ. And those are our 3 guard locking switches we have in the demo behind us. The next is we have a light scanner right here. Well, if you look here, we don't have a laser array scanner as one of our options. But what we do have, what we call an alternative device. And if I click on that, we still have the same input addresses, but I've got these addressed on our multi-function terminals. And the other thing that we have is in our advanced setting, this is a solid state device. So we actually have 2 solid state inputs, which gets rid of our pulse train. So right now, there's our 6 safety devices that we have on our demo board. What I'm going to do now is add logic. So if I drag this over, drag an AND gate. And as an AND gate, I need all of the inputs of the AND gate to be true to give me an output. So we have 6 devices. I can go up to 24 input devices on an AND gate. Here we have 6. Once we've done this, all you need to do is connect the dots. Point, click. And this creates our AND gate. Pretty simple. So boom, all 6 devices have to be true, and we'll get a true statement out of this. From there, we can go to an immediate off. Now, the immediate off, it automatically went to addresses 18 and 19, which are our dedicated ones, but we can select from our other 2 outputs or our plug-in module, which is non-safety. Here, I'm going to add a 3rd output to it, and I'm going to use terminal 20. And terminal 20, if you remember, it can be a standard output, or we can make it single wire safe. Now here we have the ability to go auto manual on our reset type. So I'm going to click manual, and I need to create a reset button. So if I go up here and click reset, I can drag it all the way down, stick it in the first open slot. Now it gave us address 10. This is non-safety rated. So with it, you can use your safety rated inputs, but why waste valuable money for these terminals, as well as your multi-purpose. Here's our plug-in terminals and where they're located. And then notice here also, we have these 16 bits for our communication inputs. These are tags in the database. And what this allows us to do is we can put the reset on the touch screen, and that reset can communicate or can toggle one of these bits from 0 to 1. And this we can use as our reset input. For our demo here, I'm going to use the plug-in module that we used and input 0. Now, when I go to reset input, notice that said safety monitoring function 7, and it appears here. All right, feedback. Let's go ahead and add feedback. And the feedback gave us safety monitoring function 8. And we're going to change this. We're going to bring 2 in from our safety contactor, and I've got them addressed at 2 and 3. All right. So we go back to here, and now you'll see 8 safety monitoring function 8 is done. And basically, we've created our safety circuit. One thing I am going to add to this is our guard locking switches. Our gate switches are all 3 guard locking switches, and they're all power to lock. So I'm going to give us the ability to unlock these devices, and I'm going to use a delay off output. And because these are not safety rated, I can go ahead and use this as use the outputs from our plug-in modules. I'm going to add a 3rd because we have 3 of them. And here, I'm just going to connect directly from the e-stop to here. So whenever the e-stop's depressed, we'll lose power here and we'll unlock our guard locking switches. All right, So now our safety circuit is complete. I can go here. And the first thing we can do is there's this build function. And this build function is going to compile our program, and it's going to tell us our faults. And I on purposely created one fault, and one of them looks like I did actually miss something and have a fault. So with these being said, it tells you exactly what your faults are. If I go over here to the logic editor, I intentionally did not connect these. So let's go back now and build it. It says I still have one. This is output function one, delay off. Didn't define it, the reset. So go back to the editor, go back up here, and I'm going to change this reset from auto to manual. Could have used the same reset function, but just to show a variety. The other thing I didn't do, I didn't give it a time delay. And here, I'm going to give it a 2-second delay so that when it trips, we have 2 seconds, then we unlock and give an output to our unlock commands. Now, if I build it, now I have successfully built no errors. So from here, and you got to forgive me, I have a box here that it shows Leanne, and it keeps getting in the way no matter where I move it, so forgive me. So from this right here, I'm going to go ahead and do a download to our program. Now, I've got this connected via USB cable here, but in order to connect it, I actually have to go under virtual chassis. So this is a got-you, and unless you know about it or read the manual, you have to know it's virtual chassis. It showed me 2 CR30s, it crossed out one. This is obviously the CR30 that I'm connected to. Click OK, and we're downloading. One thing I want to point out while we're downloading is our manual for the CR30 is located right here. So if you ever need help, you can click on the manual and view it. So now it says that it's successfully downloaded. I click, and we now have the program we just configured running in the CR30 in our demo back there. And I can view the logic live, and it shows that all my input devices are ready to go. My logic is here, ready to go, but now my output's blinking. So this is an important thing to understand. Whenever you see a blinking output, whether it's on a relay or in here, it means it's waiting for a reset. So now I'm going to go reach over here on my demo board, and I'm going to click the reset, and we should see everything go live. And now I do have outputs and everything is working. If to show you that we're live, if I click the light curtains, I've tripped the output and my light curtains go on and off. So we have good diagnostics even from a free software. And that's it. We have successfully created the same program that quickly, that easily for the demo board behind me. One thing that you have to do after this is very important, is you have to test everything. Make sure your safety circuit works and try to defeat it. This is an important validation part of your program. Once you have succeeded in validating it and you're 100% sure that this is a tested and true safety program, there's a verification tab here. And if you click it, it will ask you a series of questions. And if yes is your answer, just check the boxes. Once you've checked all the boxes, it'll say generate your verification ID. Click generate, hit yes, shuts down the relay, and we click OK. And now we wait as it verifies, says successfully verified, and it gives you this verification ID once you verify. This is important to know because this is your safeguard. If anybody is to alter the program in your CR30, they would have to re-verify it. And if they do that, it would change the number. And so you write this number down, and if anything should ever happen in the future, the first thing you do is check your verification ID and make sure this is the program that you downloaded into your CR30. The one big thing to understand that is if you don't verify your CR30, it will fault every 24 hours, and it'll do a hard fault. And this hard fault, the only way that you can recover from the fault is to remove power from the CR30 and then bring power back on it. True story here. I had a customer call me and say that they were having intermittent faults with their CR30, and this CR30 was on a line that an OEM had brought in to the plant. They did not run this line 24 hours a day, 7 days a week. They only ran it for 2 or 3 hours a day, only on certain days when they needed it. And they could not figure out why they had this intermittent fault tripping. And they even put a chart recorder on the power to see if the power was faulting out. So I told them, this is too complicated. I can't do this over the phone. They're just down the street. Why don't I run over there and see if I can help them troubleshoot? So the first thing I did is they didn't even have the software. So I plugged my laptop into their CR30 and I uploaded the program. And I looked and I did not see a verification ID. And I asked one of the gentlemen there, I said, can you look in the panel and tell me if that run light is blinking on that CR30? He said, yes, it is. I said, gentlemen, this is unbelievable. The OEM did not verify this CR30. And with this not verified, this thing's going to trip every 24 hours. And two of the guys said, at 3 o'clock. So we verified it, gave them training because we troubleshot it that fast. And they now have quite a few CR30s in the plant. So important to verify it. Don't call me and say your CR30 is not working and have me ask you if the run light's blinking. So with that, one of the things I wanted to prove real quick, got that block in my way again, is the CR30 is actually of a good value. Here our actual list price of the CR30. So it is basically list for about $775. The Ethernet module, just over $300. So if you buy our simplest single input relay, that lists at $240. So if you have 3 devices and 3 relays, you're getting really close to the price of the CR30. But the thing is, you don't have expandability. Definitely if you have 4 devices, you've gone over the top. Our other relay that allows you to put 2 devices on one relay, you can see its price. So if you have to use 2 of these relays, you can get that for the price of the CR30 and have expandability. Check out this. This is the price, list price for a Mac controller. Now this can do up to safety or 8 mats, but a lot of people only need 1 and you still have to buy this controller and the price for it. So the CR30 can do that. Muting light curtains. I couldn't believe this price. This is another true story. And Mike, I hope you're out there in the audience. You can verify this story for me and give me a testimonial. Had a customer, Mike, call in, said he needed a part number and a price for a muting module for his light curtains. And when I saw the price here, I said, this is crazy. And so I said, Mike, is there any chance that you have other devices, safety devices in this line? And he said, yes, he got an e-stop and a couple gate switches. So I asked him, can you come down and look at my demo of the CR30? And while he was coming in transit, I went ahead and put 2 right side sensors on the demo board, and I configured the muting light curtain application in the CR30. I showed him and demoed him. He loved it. And then I asked him, what's your PLC that you're using with this? He said, Control Logics. So I asked him if he wanted to see this Ethernet module and what it can do. No, he didn't want to say it. I said, please, It's worth your time. Look at this. And so I gave him a demo of Studio 5000 with the add-on profile and what it provided. He left from this demo board, went around the corner to our counter, and he bought a CR30 and an Ethernet module. And since he's purchased quite a bit more. Mike, I hope you're out there. You're supposed to be. I know you got an invite. So there is actually great value in the CR30. It's cost effective when you actually look at a machine and the fact that you normally have more than one e-stop on the device. So with that, I have finished the presentation and the demo, and I ask if there are any questions.
Hi, Kevin. We don't have any live questions in the chat right now, but we'll allow a few minutes to see if anyone has any questions. So if you want to ask Kevin something, please go ahead and type that into the chat, into the comment section. While we wait, I'd like to remind you all that you can reach us at the email address there on the screen, and macamaclive@mc-mc.com. You can send us your questions even after this live stream has ended, and we'll pass them along to Kevin, who will reach out to you directly with an answer. Just be sure to let us know the name of the session and your email so we can get your questions to the right person.
Leanne, I forgot to show them something.
Oh, great. Go ahead.
All right, so while we're waiting on questions, I do want to show you another feature of this connected component workbench. When you have complete, when you have verified and validated, and the project's finished, up here in your logic editor is this little tab that looks like a printer. If you click on it, this will give you the documentation, allow you to do a Word or a PDF. Click OK. I've already done this in the past. And it'll create a document with your documentation. This documentation is very useful. It tells you, first of all, what version of CCW you used when you configured this, what version of firmware you have in the CR30 when you downloaded it, and then it actually shows you your verification ID, so you have a record of your verification ID that you can print and keep in a safe place. It also shows you how you configured your LEDs. It shows you your slots and what you did to your plug-in modules. Tells you your Ethernet IP address that you configured it with. Then the last thing it shows you is your actual code that you wrote to configure the CR30. So this becomes a really good, useful document to keep on hand. All right, just wanted to show that off while we waited for questions. Dan, have we had anything yet?
Well, it doesn't look like we have any right now, Kevin. So if you guys have anything, go ahead and jump in right now.
I'm either real boring or I covered it all.
I think you covered it all. I thought it was great. We have a lot of great jobs, Kevin, and great demos. So there's that.
Excellent. All right, thank you guys. I appreciate that.
So I think we're going to sign off, and I hope that the session was informative and engaging for all of you. If you're out there and you haven't already subscribed to our McNaughton-McKay YouTube channel, we ask that you please do that. Oh, we got a question, Kevin.
Oh, great.
Ready? All
yes.
right. Are there special DC power supplies for these?
So these are rated. They ask for a class 2 power supply, and there is an actual CR30 power supply that's rated at only 1.6 amps. I pulled up the wrong thing here. That you can use, but as long as you use a class 2, there's the power supply right here. Leanne, your box keeps getting in the way. So there's
That's a Cisco thing. I can't change that. Sorry.
But yeah, they recommend a class 2 power supply, essentially at 24 volts. It's anything under 4 amps. And they do have a power supply that piggybacks, and I don't know if you can see it on our demo, but we actually have the CR30 power supply located right there. Sorry, probably blocked it, didn't get you to see it, but it's up there.
That was from Chris Simmons. I hope that answered your question. Do we have anybody else out there?
Let's see. Yeah, thank you all for attending, and I appreciate your time.
Okay, great. So subscribe to our YouTube channel. We look forward to seeing you again next week, live, virtually. We hope you have a great day. And if you're someplace where it's snowy and cold, stay warm.